This is CPM Precalculus, Chapter 3, number 48. So here we're given a triangle CAB, and it's an isosceles triangle with side CA congruent to side BA, right? CA is 5 units, and it's congruent to BA, it's also 5 units. Okay? The congruent sign actually has a little squiggly on top, so let's fix that. Also, we know it's a right triangle in the picture, so it's an isosceles right triangle. I'm going to include that keyword here because that's what we're given in the picture. Okay, so part A says to find the exact length of BC, this side here, right? BC is also, if we relabel it, is going to be little a, just like this is little c and this is little b, right? Well, if we're going to find this side, what we can do is basically, since it's a right triangle, we can use the Pythagorean Theorem. Another way we could do this is to notice that since this is an isosceles triangle, these two angles are congruent as well, and so these are both 45 degrees, right? And since those are 45 degrees and that's 90, we know it's a special right triangle with the property of, given that this is side x and x, this is square root of 2 times x in length, right? But let's go ahead and use the Pythagorean theorem, because we already know square root of 2 times x, when x is 5, is square root of 2 times 5. So let's go ahead and solve this using the Pythagorean theorem. But the Pythagorean theorem, we know c has to be the hypotenuse. So c is actually a in our drawing, or side BC, right? C here, so side BC squared is equal to a squared in the picture, and that's equal to just 5 squared plus 5 squared, right? So that's 25 plus 25, or 50. So we know our side BC, or side A, is equal to the square root of 50, which is square root of 25 times 2, and we know square root of 25 is just 5 times square root of 2, right? Just like we had if we were to say, well, x is 5, so square root of 2 times x is square root of 2 times 5, right? So this is the side BC in simplified radical form, right? It is simplified in radical. Okay, so part B says to write the sine ratio for angle C. So remember, angle C is this angle right here, right? So let's go ahead and write the sine ratio. Sine of angle C, we know from SOHCAHTOA that sine is just OH. It's opposite over hypotenuse, right? The opposite side from angle C here, the opposite side is over here 5. The hypotenuse of the triangle is this side we just solved for, which is 5 square root of 2. Okay? So if we reduce this fraction, this is just 5 over 5 makes it 1, right? These cancel out over square root of 2. And we want to go ahead and simplify this. We don't want a square root in the denominator, and that's going to be part C. Normally, I would go ahead and do part C up here. So let's do that. Part C is going to be right here, right? It says rationalize the denominator of the fraction you got in part B by multiplying the numerator and denominator by square root of 2. Okay, so multiplying the numerator by square root of 2 and denominator by square root of 2 is just multiplying by 1. Okay, so this right here is part C. We multiply across, we get square root of 2 in the numerator, and square root of 2 times square root of 2 is just 2 in the denominator. Okay, so this here is simplified radical form and doesn't have a square root in the denominator, right? So it's a rationalized denominator. All right, so that ends for us CPM Precalculus, Chapter 3, number 48.